Hello guys, welcome to Leetcoding. In this video, we are going to see the Leetcode problem number 198, house robber. So let's get into the problem. So the problem statement is, you are a professional robber planning to rob houses along a street. So each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. So, given an integer array nums representing the amount of money of each house, so we need to return the maximum amount of money you can rob tonight without alerting the police. This is the problem statement given. So now let's define the problem. So the first step to solve any problem is to define the problem clearly. So they have mentioned that consider yourself as a robber planning to rob each house along the street. So each house has some certain amount of money stashed in it. So you can there's a constraint that you cannot rob each adjacent houses since it will automatically contact the police. So we should not get caught to the police, right? So we should not rob adjacent houses. So given an array nums representing the amount of money of each house, so we need to return the maximum amount of money we can rob without alerting the police. So yeah, let's see. So the input for this problem is nums representing nums array representing amount of money stashed at each houses. So at each house, so output for the problem is maximum amount you can rob without getting caught to the police. So without alerting the police, without police alert. So these are the input and output for our problem. So maximum amount you can rob. When we cut this point, we can just sum up the amounts and return the answer. But since we have without police alert, this is the main constraint to be concentrated in this problem. So when will we get the police alert? So police alert is equal to robbing at two adjacent houses. So when we rob two houses which are adjacently present, we will get the police alert. So there will be police alert. So this condition should be avoided. So this is it. This is all about a problem definition. So how can we rob without uh, police alert? So this is the main condition which you have to do concentration. So now we have successfully defined the problem. So now let's get on to the approach for solving this problem. So the second step is nothing but approach. So you'll be having many houses. Let's say first house, second house, third house, fourth house, fifth house. So let's mark this as H1, H2, H3, H4 and H5. So these are separate houses. So each houses will be having some of the money within them. So the some amount of money will be stashed within each houses. So there's a thief here. He need to rob amount without alerting the police. So he is the thief or robber. So this thief needs to rob houses such that maximum profit is gained. Max profit, that is maximum amount is robbed, and no police alert. Police alert. This is the constraint. This is all about our problem definition. So what can the thief do? So let's say the thief robs the first house. So this house is robbed first, and the thief can also rob the second house directly. So at the first time, so uh, let's try to find out maximum amount of amount that can be robbed when reaching each houses. So when we reach house 1, the maximum amount that the thief can rob is nothing but only the H1 profit. So the amount of money present at H1, only this amount can be robbed. This is the maximum possible amount that the robber or thief can gain. So when he reaches H2, so he can, when we reach H2, the maximum amount of money the robber can have is nothing but only the amount of money present at H2. So he cannot rob H1, so we don't add the H1. So only H2 is added. So what is the maximum amount when we reach house 3? So when we reach house 3, we can get maximum amount of H3 plus H1. So what we have done, it's nothing but when we reach H3, we can rob house 1 and reach house 3, or yeah, that is the which will give us the maximum profit. So we are adding H1 plus H3. So we cannot include H2 because H2 is adjacent. When we rob house 3, we can only rob houses which are not adjacent to H3. So we don't consider the upcoming houses, we are just considering the previous houses. So from previous houses, only H1 profit can be added here. So now let's check with H1, H4. So in house 4, when we reach house 4, we need to find the maximum profit we can gain now. So the maximum profit that we can gain from here is nothing but robbing the house 4, H4, that is H4, amount of H4 plus we can either reach H4 from H2 or H1. So there are two possible ways to reach H4. Either the thief can rob the house 1 and directly jump to H4, or the thief can jump from H2 to H4. So H4 can be reached from two of the possible ways. So it can be reached either from only from two of the possible ways. There are also cases in which H4 can only reachable from two places, right? So H1 and H2. So we'll try to find out the maximum of amount that can be robbed from H1 and H2 and add it up along with amount present in house 4. So amount present, the amount, there is a maximum amount that can be robbed while we reach H4 is nothing but amount present at H4 plus amount, that is maximum amount that can be robbed. Let's say MAR, maximum amount robbed when we reach H1, or maximum amount dropped when we reach H2. We'll try to compute the max value of both these values. So when we'll add this up with amount present at H4. So this will be the value for maximum amount that can be robbed when we reach the H4. Now we are going to find out the maximum amount of money that can be robbed when we reach house 5. So what will be the value? So when we reach house 5, we can rob the amount present at house 5. So amount present at H5 plus we can either reach H house 5 from H3 or H1. So there are two possible ways in which we can reach H5. So there are also many other ways, like we can even reach H house 5 from house 1, but we are ignoring these cases because H3 can be also be reached from H1. So we'll consider robbing as many houses as possible. So we don't jump directly from H1 to H5. Since there is a possibility of robbing H3, we will just jump here one house and also jump another house to reach H5. So we are ignoring all other cases except two adjacent houses, that is two houses before the adjacent house. So when we consider house 5, just check for house 3, maximum amount of money that can be robbed from house 3 and house 2. We are just taking the previous two values, that is H3 and H2. So we'll find the maximum amount robbed when we reach H till H2, comma, maximum amount that can be robbed till H3. So we are just adding it up. So finally, what we can return is uh, the values present at final two indexes will give us the result. So either H5 or H4 will have the maximum amount that can be robbed. So it is guaranteed that maximum amount that can be robbed will be present at either H4 or H5, that is the last two houses. So we can ignore all these houses. So why we are ignoring all these houses? Because we don't need to check H3, because H3's profit will also be added to H5, and H2 also will be added to the profit of H5. I mean H2's profit will be added to H4, so we do ignore all these cases. So it will be going on. So we ignore all these houses and we'll return the maximum out of maximum of maximum uh, money robbed, maximum amount robbed from house 4 and maximum amount robbed till house 5, that is the last house. So we'll just return the maximum amount robbed at last two houses till last two houses. So this will give us the answer. This is the approach we are going to use here. So we'll have example to demonstrate this approach. So we'll consider the example 2. So we have 5 houses, H1, H2, H3, H4 and H5. So we have 5 houses totally. So the thief is here, and when the amount of maximum amount he can rob when he reach H1 is same as 2, and H2 also remains 7. And then the maximum amount that he can rob when he reaches H3 is nothing but adding up previous house. So 2 plus 9, which will give us 11. So maximum amount that can be robbed till house 3 is nothing but amount present at house 3 plus amount that can be robbed till house 1. So all these values are added and stored in the house 3. Now we are going to find out maximum amount that can be robbed from house 4. So in house 4 we can either reach from H2 or H1. So we are finding the maximum amount. So maximum amount robbed for H4 is nothing but amount present at H4 plus maximum of maximum amount robbed till H2, comma maximum amount robbed till H1. So we are finding the maximum value and adding it along with the amount present at H4. So it's nothing but amount present at H4, house 4 is 3 plus maximum of 2 and 7. So 7 and 2. So this will yield us 7. So 3 plus 7 will give us 10. 10. So now we will be storing 10 here. So we are trying to reach the next house. So house 5 can be reached from either H3 or H2. So we are finding the maximum value. So maximum amount that can be robbed from H5 is nothing but amount present at H5 plus maximum amount that can be robbed from H3 and maximum amount that can be robbed from H2. So amount present at H5 is nothing but 1, and the maximum maximum amount that can be robbed from house 3 is nothing but 3, and maximum amount that can be robbed from house 2 is nothing but 7. So max will give us 7. So 1 plus 7 is nothing but 8. So we'll store 8 in the array. So now our array will be containing maximum amount that can be robbed while reaching each of the houses. So we'll find the maximum value. So, and sorry, H3 has maximum profit of 11. So this is nothing but 11. So 11 plus 1 is nothing but 12. So what mistake I have done is maximum amount of money that can be robbed from house when we reach house 3 is nothing but 11. So I have mistakenly entered 6 here. So 11 and 1 will, 11 and 7 maximum value is 11. So we'll add 11 along with 1, which will give us 12. So we'll update house 5 to 12. So finally we'll return the maximum value out of last two houses. So we'll return 12 here. So 12 is the answer. So let's check whether 12 is answer or not. Yeah, 12 is the answer. So this is the approach, and the approach seems to be correct. So for this case, I'm sure that approach will work also for other cases. So we are going to see the steps to be followed for this approach, for coding up this approach. So first step is nothing but to for we'll iterate over iterate from third house. So if third only for third house there is only one possibility, only reachable from the third house can be only be reached, we'll say it can be reachable from any of those, only reachable from first house. So third house can be reachable only from third house, I mean the first house. So for other houses can optimally be reachable from house number, let's say house number as generic term, house number minus 2 and house number minus 3. So from both these houses we can reach other houses. So we'll choose maximum value from that and add maximum amount robbed from this or this. So based on the house number we'll add it up and finally return maximum of last two house robbed money. So we'll be iterate over each house. So for only the third house we'll just check for only first house and other houses will go previous two houses and add the maximum value to the current amount present in the house. So finally we'll be returning the maximum amount present in the last two houses. So that's all about the steps to be followed. Now let's see the time and space complexity. Time and space. So the time complexity, that's nothing but big of 1 since we iterate over the complete array only one time, and the space complexity for this approach is big of 1 which is constant since we don't use any other extra space except the variables, and the approach for this problem is dynamic programming DP iterative method. So this is all about our approach and space and time complexity. So I think you'll get the clear somewhat idea about the approach we have used here. So you'll be very clear in the coding section. So let's get on to the coding section. So initially we'll check whether yeah, we'll store the number of houses in variable n nums for len. So we'll update for the third house. So third house and other house. So if n is greater than or equal to 3, what we'll do is sums of 2 is nothing but, so the array is indexed 0 indexed, so third house will be represented in the index number 2. So the index number 2 will have that is the house can be reachable from house 1. So we'll add up current value plus house 1's value, so amount of money present at house 1. So for other houses we'll iterate from 3, that is the fourth house, till last house, and we'll add up current house profit, that is the amount present in current house, plus math dot max of previous two houses. So it is nums of I minus 2, comma, not the previous two houses, previous two houses except the adjacent house. So nums of I minus 3. So we'll add this one. And finally, as we have told it, we'll return maximum value of nums of n minus 1, which will give us the last house, and nums of n minus 2. So we'll return the this value. So there is a base condition in which the number of houses is 2. So 1. So in the number of houses is 1, which is the base. At least there will be only one house. So we'll just check the base condition. So if number of houses only 1, we'll just rob only one house. So we'll return nums of 0, which is the amount present at house 1. So we have handled this base case because in this there will be a error that will be occurring in this line. So we have handled the base case. So let's take this up. It's working fine. So now let's submit it up. Accepted. And that's all about this video, guys. Thanks for watching this video. Have a great time. Happy coding.